Hello everybody, I'm Taylor and this is Daniel, and today's topic is from Unit 3, Area Study 1, Outcome 2. It is the key knowledge point of acute physiological responses to exercise in the cardiovascular, respiratory and muscular system. So the first thing we're going to look at is what acute responses to exercise actually are and why they occur. When exercise commences, the body goes through a number of physiological changes to meet the energy requirements and oxygen requirements of the activity. So therefore, the level of response is always determined by the type and intensity of the activity. So when we exercise, there's an increased need for oxygen, there's an increased need for energy, so our fuels, and the three systems, respiratory, muscular and cardiovascular systems all act and create these acute responses that we need to keep up with the function of what we're doing. So the first thing we're going to look at is the respiratory system and the different acute physiological responses we have. So firstly, we've got ventilation. I highly suggest that you write the definition down and the units that I say goes along with. So firstly, ventilation, which is how much air is breathed in or out in 1 minute, and the unit for this one is litres per minute. Then we've got tidal volume, and tidal volume is how much air is inspired per breath, and that is in the units of litres. Then we've got respiratory rate, and respiratory rate is the number of breaths taken in 1 minute, and this is in the units of breaths per minute. Now all of these work together and they all increase at the onset of exercise. Like I said, they all work together. We've got a formula for them. The formula is ventilation equals tidal volume times respiratory rate, and it's really important that you understand the relationship that they all have together to form ventilation in the respiratory system.
Okay, so now we're going to discuss diffusion, which is how the respiratory system actually allows the onflow of oxygen throughout the body. So we're just going to break up the lesson and give you a visual look at what diffusion looks like. So it's when there's a high concentration of something, it goes from a high concentration to an area of low concentration, and this is important in all aspects. So as Taylor drops a bit of food dye in, it goes from a high concentration and then spreads throughout the water, becoming lighter as it diffuses through a larger area. So the gas exchange occurs in the body, in the lungs alveolar capillary interface, and the muscles tissue capillary interface through diffusion. So this is how the blood gets from the lungs through to the blood, and that's through the capillaries that join the lungs to the blood flow. So diffusion in the lungs occurs when there's a higher concentration of oxygen in the lungs than there is in the bloodstream. So then the body will act upon this to even it out. So oxygen will flow from the lungs into the bloodstream, and CO2 will flow from the bloodstream into the lungs. And this will occur to even out the flow. And then from there, since now that the blood has oxygen, it will then take it and move it on down to the muscles. So the muscles is the opposite to the lungs. So this is where the muscle has a high concentration of CO2 in its muscle to the bloodstream, so it needs more oxygen in its blood. So the blood will allow it to flow freely into the muscle through diffusion. So this is the same process, however, the oxygen is now flowing into the muscle and allowing us to act upon this, and that's why we increase our tidal volume, respiratory rate, and therefore our ventilation, so that we can get more oxygen into our muscles and CO2 out of our blood, out of our muscles.
So now we're going to go onto a Kahoot, which we have a participant for. So the code is 1859519, and we'll start that. I'll just read out the questions so you know what questions there are. So firstly, we have, what is the definition of ventilation? How much air is inspired per breath? Dissolved substances have to pass through the cell membrane. how much air is breathed in and out, and how much air is breathed in and out in 1 minute. Then we have the ventilation equation is, and we put it in the letter form. So it's V equals TR times RV, V equals TV times RR, V equals TV times Q, and V equals SB times RR. So the next question, name this process. We've got an image, gas exercise, gas exchange, oxygen consumption, and ventilation. What are the units for ventilation? So what units are they found in? So litres per minute, millilitres per minute, litres per second, kilometres per hour. What is the difference between diffusion in the lungs versus in the muscles? So O2 levels high in lungs, low in muscles. CO2 levels low in lungs, high in muscles. CO2 levels high in lungs, low in muscles, or O2 levels low in lungs, high in muscles. Acute respiratory responses. So you've got to identify these. So we've got respiratory rate, diffusion, blood pressure, AVO2 difference, tidal volume, temperature, cardiac output, venous return, ventilation, and tidal volume, ventilation, diffusion. And respiratory rate is, this is the last question, number of breaths per second, number of breaths per minute, number of respirations per second, number of respirations per millisecond. And there we go. Those are the Kahoot questions.
So now, those were review questions on just the content we had already covered. Now we'll be looking at, you'll be given a sheet and you'll have 5 minutes to complete 3 questions. These questions are more, you have the background knowledge and now you have to build upon this. This is something that as students you get on the exam, they're not going to give you questions asking for definitions and things like that. There's definitely going to be questions which you need to expand on your knowledge. So
yeah, less identifying, more being able to expand on what you already know.
So the first one is, what are the factors, the 2 factors that affect ventilation, and how do these factors affect it? So I'm not going to give you the answer, but I'm going to tell you where to look. So you obviously it's the type and intensities, which is what we learn, and then the factors that how do these affect? We talk about like different exercises. We need different oxygen consumption. So it's bringing back prior knowledge that we've already learned. And then another question we have is suggest why there's a difference in between males and females. And this is something that we again need to bring on our prior knowledge and obviously our new learnt knowledge. It's obviously that often males are way more and have larger lungs genetically, so then therefore we're going to need more oxygen to come in, and then obviously that's why our tidal volume is higher. The last one is the relationship between respiratory rate, tidal volume and ventilation. So we've given you a background knowledge and we spoke about the equation that we mentioned before. Now we want you to expand on that and explain how respiratory rate times tidal volume therefore increases ventilation during exercise.
Yep. So we just want you guys to ask any questions if you need to. They're pretty straightforward. You've got all your notes from our presentation. It's just about being able to use your previous knowledge, which we expect you to be able to do, and you're also welcome to use notes from previous topics or textbooks if needed.
Yeah. So you have 5 minutes.